They had the skulls of crocodiles, the bodies of giants, and a relationship with water unlike anything else in the age of dinosaurs. Today, we explore Spinosauridae and why Spinosaurus Mirabilis is rewriting what we thought we knew about them. 1. What are Spinosaurids? Spinosaurids were medium to very large theropods that lived primarily during the early to late Cretaceous period, roughly 130 to 90 million years ago. The family takes its name from Spinosaurus and phylogenetically divides into two main groups: the Baryonychinae, named after Baryonyx, the earlier and somewhat less aquatically specialized branch, and the Spinosaurids, which took semi-aquatic adaptations to remarkable extremes. Both lineages share a distinctive suite of features: elongated, low-slung skulls, nostrils positioned far back on the snout, possibly allowing them to breathe while partially submerged, and reduced tooth serrations. These traits evolved convergently with modern crocodilians, almost certainly reflecting a similar ecological role, hunting at the water's edge. 2. Baryonyx walkeri. England, January 1983. An amateur fossil hunter named William Walker was exploring a clay pit when he noticed an unusually large claw poking out of the rock. He broke it free and brought it to the Natural History Museum in London, where scientists quickly realized it was something extraordinary. The claw alone was over 30 centimeters long, roughly the length of a human forearm. A subsequent excavation of the site recovered a remarkably complete skeleton for a large theropod, around 60% of the animal, the Baryonyx. But even more crucial, the contents of its stomach region were found. Preserved among the ribcage were fish scales and partially digested bones belonging to lepidotes, a large ray-finned fish common in early Cretaceous waterways, as well as bones from a young iguanodon, suggesting Baryonyx wasn't exclusively a fish eater, but was at least an opportunistic scavenger or predator of terrestrial prey as well. It was finally named Baryonyx walkeri, a double tribute to the fossil's most distinctive feature. Baryonyx means heavy claw, and to the man who found it. Around 8 to 10 meters long and weighing up to 2 tons, it was an impressive animal. It lived around 130 million years ago, and its most immediately striking feature was obviously the skull. Where most large theropods had deep, powerful jaws built for biting and crushing, Baryonyx had a long, low, narrow snout that widened into a distinctive spoon-shaped rosette at the tip, almost identical in layout to a modern gharial, the slender-snouted crocodilian of South Asian rivers. This shape is a classic convergent adaptation for catching fish. The narrow profile reduces water resistance when snapping sideways at fast-moving prey, while the rosette at the tip helps grip slippery bodies. The jaws were lined with around 96 teeth, nearly twice as many as a typical large theropod, conical, lightly serrated, and ideal for piercing rather than slicing. The nostrils were positioned further back along the snout than in most theropods, a feature shared across Spinosaurids and possibly linked to partially submerged hunting, keeping the breathing apparatus clear of the water while the jaws worked below the surface. The forelimbs were powerfully built and unusually large relative to the body, terminating in that famous thumb claw. It dwarfed the hand claws of most theropods and was probably used to pin or rake prey rather than as a slashing weapon. Finally, Baryonyx walked on 2 legs like other theropods, but its hind limbs were proportionally longer and its bone density lower than later Spinosaurids, suggesting it was a competent terrestrial animal living an amphibious rather than fully aquatic lifestyle, wading and lunging at the water's edge rather than swimming after prey. 3. Baryonychinae. The earlier branch. The Baryonychinae subfamily also includes several other members. Suchomimus means crocodile mimic. Over 10 meters long and with a body mass ranging from 2.5 to 4 tons, Suchomimus had powerfully built forelimbs and that unmistakable elongated snout. It patrolled river systems roughly 110 million years ago, sharing those waterways with giant crocodilians, implying genuine ecological competition, possessed a modest sail or ridge along its back, not as dramatic as Spinosaurus's, and it likely used its huge claws to snag large fish, much like a grizzly bear catching salmon. Suchomimus also had lighter bones compared to Baryonyx and Spinosaurus, further proof that it was a wader and ambush hunter rather than a swimmer. Ceratosocops and Rhiparovinator fossils were both found on the Isle of Wight. Ceratosocops means the horned crocodile face, referring to small bumps and rugose textures on the skull above the eyes and along the snout, which in life may have supported low keratinous horns or prominent brow ridges, much like some modern crocodilians carry ornamentation on their skulls. Riparovinator means riverbank hunter, reflecting its presumed lifestyle of hunting aquatic prey along ancient waterways. Riparovinator is distinguished by specific cranial details, such as a notched dorsal margin of the orbit and a deeply inset facial nerve foramen. Fossil evidence includes tail vertebrae with unusually long neural spines, suggesting a deep, possibly paddle-like tail that could have aided in aquatic propulsion, similar to but less extreme than Spinosaurus. Protathlitis, the champion, named by the researchers as a tribute to the football club Villarreal, and Rio Havanatrix, La Rioja Huntress, named after the Spanish province of Discovery, are particularly valuable scientifically because reinforce the idea that early Cretaceous Europe, not just North Africa, hosted multiple semi-aquatic theropods simultaneously, occupying coastal lagoons, estuaries, and freshwater basins across the continent. Finally, we have Suchosaurus, the crocodile lizard, with two species, Cultridens and Gerardi, which remain dubious, while Cristatosaurus, the crested lizard from Africa, is generally synonymized with Suchomimus. The Baryonychines are our oldest and best understood Spinosaurids, and the evidence for their fish-eating habits is remarkably direct. They retained relatively longer hind limbs and comparatively lower bone density, suggesting they were capable terrestrial walkers living more amphibious than fully aquatic lifestyles. But if Baryonyx and the Baryonychines were already impressive, the Spinosaurus shows just how far these adaptations could go. 4. Spinosaurus Aegyptiacus, the river giant. Spinosaurus Aegyptiacus, the Egyptian spine lizard, was first described by Ernst Stromer in 1915. But the original fossils were destroyed during the Second World War, when Allied bombing raids struck Munich and the museum took a direct hit. For decades, Spinosaurus was known almost entirely from Stromer's descriptions and drawings. It wasn't until new expeditions to Morocco in the 2000s, and especially 2014 onward, that substantial new material finally allowed scientists to reconstruct the animal in detail, revealing, to widespread astonishment, just how peculiar and aquatically adapted it truly was. Spinosaurus possessed dense, compact limb bones, a feature seen in modern diving birds and semi-aquatic mammals, where increased bone mass acts as ballast against buoyancy. Its hind limbs were proportionally short but robust, well suited for wading and swimming. Its nostrils were far back on the skull. As we've seen for the other Spinosaurids, this allowed it to keep its snout submerged while still breathing and freed up the sensitive snout tip for detecting and catching prey. Spinosaurus's conical, interlocking teeth formed a cage-like trap for slippery fish. This arrangement appears repeatedly across fish-eating animals throughout the fossil record, from ichthyosaurs to gharials, because it simply works. The teeth were only lightly serrated or entirely smooth, a significant contrast to predators like T-Rex, whose heavily serrated teeth were essentially steak knives for slicing through flesh. Spinosaurus Aegyptiacus carried one of prehistory's most mysterious structures on its back. The sail was formed by elongated neural spines, and in some individuals exceeded 1.5 meters in height, meaning the sail alone could rival the height of an adult human. What it was for, nobody fully agrees on. Thermoregulation, the most intuitive idea, but it was largely dismissed because of the lack of canals for blood vessels in the spinal processes. A hump, not a sail. Some researchers argue the neural spines of Spinosaurus favor bison-like humps rather than sails because they are dissimilar to pelycosaur spines. The animals we're most confident actually had sails. Under this view, the structure stored fat. Display. The display hypothesis is considered likely given the sail's large surface area, which would make it a distinguishable characteristic that could determine mating success. A fourth, more exotic idea. Some propose the sail acted like a boat's centerboard, aiding underwater maneuverability, though critics argue it was too flexible and poorly shaped to function hydrodynamically. The honest conclusion is that no single hypothesis has won out. It likely served multiple purposes, and the debate is still very much alive. Spinosaurus is also the longest carnivorous dinosaur known, though the exact figure is debated. Estimates based on the available material range from around 14 to 16 meters, with some outlying suggestions of up to 18 meters. Even at the conservative end, it exceeds T-Rex and Giganotosaurus in length. Weight is more contested. Most estimates place it between 6 and 9 tons. However, even if on paper it was broadly comparable to large predators, they were built for completely different purposes. T-Rex was muscular and built for bone-crushing force. Giganotosaurus was a pursuit predator, built for speed and slicing wounds. Spinosaurus was something else entirely, more lightly framed than both. Its body shaped not for hunting on open ground, but for the river. Nevertheless, the region where Spinosaurus was living 95 million years ago, the Chem ecosystem, has been described as one of the most dangerous environments in the fossil record. Alongside Spinosaurus, it hosted enormous crocodilians, giant sawfish, lungfish, coelacanths, and Carcharodontosaurus, a massive land-based predator rivaling T-Rex in size. The presence of two apex predators of this scale in the same ecosystem is unusual and suggests strong ecological partitioning, Spinosaurus dominating the aquatic and semi-aquatic niche, Carcharodontosaurus, the terrestrial one, with enough resource separation to coexist without direct competition driving one to extinction. Spinosaurus had also an unusually deep, laterally compressed paddle-like tail with very tall neural spines and likely high flexibility. A 2020 study found it generated much more thrust in water than typical theropod tails, supporting tail-powered swimming. But a 2022 reappraisal argued the tail alone did not make Spinosaurus a strong diver or pursuit swimmer, instead favoring a semi-aquatic shoreline predator. Whether Spinosaurus was a dedicated swimmer, a diver, or primarily a wading predator remains one of paleontology's most spirited debates. The anatomical evidence for substantial aquatic adaptation is difficult to dismiss, but as we'll see, new evidence adds important nuance to how we imagine these giants actually living. 5. Spinosaurus Mirabilis, the Hell Heron. The story begins in 2019. Somewhere in the central Sahara of Niger, a local Tuareg guide on a motorcycle leads Paul Sereno's team across the desert to a remote site called Gengibi. There, half buried in the sand, they find a strangely curved bone and some jaw fragments. They collect them carefully. At this point, nobody knows what they are looking at. 3 years later, Sereno returns with a larger team. They find 2 more of the same curved bones. And then slowly, the realization sets in. These are cranial crests, and they belong to something nobody has ever seen before, Spinosaurus mirabilis. The species name, Mirabilis, is Latin for astonishing. It earns it. The defining feature of Spinosaurus mirabilis is a massive, scimitar-shaped crest projecting from the top of the skull. Nothing like it has been documented in any other Spinosaurid. Based on the crest's surface texture and the network of blood vessel channels inside it, the researchers believe it was sheathed in keratin, much like the casque of a modern cassowary, which would have made it even more dramatic in life. The crest may have reached 50 centimeters in height, making it potentially the tallest cranial crest of any non-avian dinosaur on record. Spinosaurus Aegyptiacus also possessed a crest, but a far smaller one. The crest and sail together would have made Spinosaurus mirabilis a visually striking animal, probably used for signaling to rivals and attracting mates, much as elaborate head ornaments function in modern birds. The fossils come from the Ferric Formation, dating to roughly 95 million years ago, placing Spinosaurus mirabilis as one of the last surviving Spinosaurids at the closing chapter of the family's long radiation. But most significantly, Gengibi lies some 500 to 1,000 kilometers from the nearest ancient marine shoreline. This is the farthest inland that any Spinosaurus has ever been found. Nearby, partial skeletons of long-necked sauropods were buried in river sediments, pointing to a forested inland environment laced with river channels, not a coastal delta. This matters enormously for the ongoing debate about Spinosaurid ecology. Previous hypotheses of full aquatic diving were largely built on coastal deposits. Sereno envisions Spinosaurus mirabilis instead as what he calls a hell heron. An animal that could wade confidently into 2 meters of water on sturdy legs, but spent much of its time stalking the shallows for the large fish of its day, some of which could exceed 3 meters in length. Not a diver, not a weak swimmer washed around by currents, a powerful, specialized wader. Spinosaurus Mirabilis and Aegyptiacus are 2 contemporaneous species of the same genus, each enormous, each fish-hunting, each with distinctive visual displays, but separated by hundreds of kilometers of ancient landscape. Same era, very different environments, one coastal, one deep inland. It suggests the genus Spinosaurus was more ecologically flexible and geographically widespread than anyone had previously appreciated. 6. Spinosaurinae, the aquatic extreme. Alongside Spinosaurus, the Spinosaurinae subfamily includes several other remarkable animals found across South America, Europe, and Asia. Irritator, with a name that reflects the exasperation researchers felt upon discovering the fossil had been heavily modified before reaching scientific hands, likely to inflate its commercial value, had extremely narrow jaws and slender teeth optimized for fish capture. The specific name is Irritator challengeri, named after Professor Challenger, the fictional explorer from Arthur Conan Doyle's The Lost World. Closely related is Anguittarama, the Noble One, frequently considered a junior synonym of Irritator, though subtle cranial differences continue to be debated. Moving to Southeast Asia, Ichthyovenator, the fish hunter, stands out for having a neural sail divided into 2 separate humps, one of the most unusual spine configurations known in any theropod. Whether this served in display, thermoregulation, or species recognition remains unresolved. Siamosaurus, the Siamese lizard, is currently known only from teeth displaying typical Spinosaurian characteristics. Valabona venatrix, the Valabona huntress, further expands the European record for this lineage. Cynopliosaurus, the Chinese pliosaur, originally described as a marine reptile before reassignment, hence the pliosaur in its name, remains debated in its placement. Fragmentary North African material attributed to Sigelmassasaurus and Spinosaurus americanus is generally treated as synonymous with Spinosaurus Aegyptiacus. Oxalea has similarly been proposed as a distinct genus, but is frequently synonymized. Spinosaurines represent the more derived branch of the Spinosauridae family. Even longer snouts, more reduced tooth serrations, shorter hind limbs relative to body size, and the dramatic elongated neural spines that define the group visually. Beyond the 2 principal subfamilies, some discoveries occupy uncertain phylogenetic positions. Iberospinus, the Iberian spine, displays a mosaic of features placing it near either the base of Baryonychinae or the divergence point between the 2 subfamilies. Camarillosaurus, the Camarillus lizard, once classified as a ceratosaur, a completely unrelated theropod group, has been reinterpreted as a possible Spinosaurid, illustrating how fragmentary material can obscure evolutionary relationships. Most intriguingly, Ostafricosaurus, the East African lizard, may represent one of the earliest Spinosaurids yet identified, potentially pushing the family's origin back tens of millions of years earlier than previously thought. Spinosaurids challenge almost every assumption we once held about large predatory dinosaurs. We see a lineage that repeatedly, across multiple continents and tens of millions of years, found success at the water's edge. Spinosaurus Mirabilis deepens the story. It is a reminder that even the most famous dinosaurs still have surprises waiting in the rock.